Problem 58 in the book shows a 50 kilogram circular piston shown in figure P18.58 that floats on 0.12 moles of compressed air. Part A asks, what is the piston's height h if the temperature is 30 degrees Celsius? And Part B asks, how far does the piston move if the temperature is increased by 100 degrees Celsius? To tackle this problem, we first need to identify what we're solving for and how we can apply that to equations that we need. So in this case, since we're solving for H, let's think about any equations that apply to gases that might involve B. The first equation that should come to mind is PV equals nRT. PV equals nRT has volume in it. Volume is equal to, in this case, pi r squared H, and that's where we can get our height from. So let's solve for our numbers. First, pressure. Pressure can be found by a force over an area. This force over area being the force of gravity over the area of our piston. Our area for our piston being pi r squared, so that gives us a total pressure of 62,389 pascals. But there's also that 1 atmosphere above the piston that's also pushing down on it, adding to the pressure. 1 atmosphere is equal to 101,325 pascals. Adding those two pressures together, we get our total pressure of 163,715 pascals. Now we simply plug it into our PV equals nRT equation, but first we solve for volume. Volume being equal to nRT over P, RT being 273 plus 30, and that's 303 Kelvin. Plugging in our numbers for volume, we get a volume of 1.846 times 10 to the minus 3 meters cubed. Then, plugging that into our volume equation and solving for H, we get a total height of 0.235 meters or 23.5 centimeters. In my opinion, the hardest parts of A are identifying that the 1 atmosphere of pressure above the piston also adds to the pressure, and solving for H from the volume equation. Because you don't know how to solve for H, then you're just sort of stuck at the volume part, not knowing what to do after that. For part B, it's the same calculation as part A, but this time with a different temperature, as it increases by 100 degrees Celsius, meaning that our new temperature is going to be 273 plus 100 plus 30, giving us the total temperature of 403 degrees Kelvin. Now, plugging that into our original volume equation, we get a new volume of 2.455 times 10 to the minus 3 meters cubed. Plugging that into our height equation once again, we get a new height of 0.312543 meters. And then subtracting that from our original height, we get a height difference of 0.078 meters. In my opinion, the hardest part of this problem is just identifying that it increases by 100 degrees Celsius instead of 100 degrees Celsius. Because if you make that mistake, your calculation will be slightly off due to the difference in temperature. Other than that, it's the same calculation as you did in part A, making this problem a little bit easier. If you guys need more practice, I recommend looking at the other explainer video problems because they are really good practice for this because they all involve pistons. Anyway, that's all from me for now. Thanks for watching.